Welcome to this episode of the online classes. My name is Numerical, your teacher. I'm a teacher of mathematics, economics, and commerce. I hope you enjoy the lesson, and I hope you're keeping yourself safe from the global pandemic that is coronavirus. Please wash your hands, stay safe, keep a social distance, and God will be our protector. And today, our topic is numerical concepts. Many of us have heard about numerals, like some of us were back in primary. We studied about Roman numerals. The word numerical comes from numerals, and in numerals we basically look at numbers. Numbers we have numbers are useful in our day-to-day life. For example, we can count items in our homestead because of numbers. We can store information, store data. We know our ages because of numbers. We know how many kilograms of rice we have in our store. We know we are able to count how many hens are around our home because of numbers. So numbers are useful in counting, storing information, storing data. In business transactions, you're aware that this kilo of rice costs 3,000. This kilo of sugar costs 2,000, all because of numbers. So the numbers are very crucial, and it is a very important topic to learn about. And basically, under the numerical concept, like I said, we shall be looking at numbers. Under numbers, we have very many subtopics, and we shall basically look at the types of numbers. Of course, if you know the types of numbers, then it is going to introduce us to adding, multiplying, subtracting numbers. It's going to introduce us to different kinds of numbers like fractions. We shall be able to know the different types of fractions, stock of improper fractions, stock of the proper fractions. We have other types of numbers that are called decimals, decimal numbers. All shall be covered under numbers. So for the start, we have types of numbers, and my first type is called natural numbers. And the natural numbers are also counting numbers. So it has two names, natural numbers as well as counting numbers. Like I have said, we use numbers in counting. And in our counting system, it's a 10-digit system. We call it counting numbers because they are the ones that we use in counting. So the counting numbers start from 1. My set of counting numbers or natural numbers will be denoted by capital N. Sets are denoted by capital letters. Capital N, and my N is given by, we start from 1. I have 1, 2, 3, 4, 5, 6, 7. I put the 3 dots to show that my numbers are continuous. They run up to infinity. Counting numbers are numbers we use to count, and they're also called natural numbers. They run from 1 up to infinity. And my other type, which is number 2, is whole numbers. Whole numbers are more like the natural numbers. I know many of us confuse the two, but then whole numbers, when we add a 0 on the natural numbers, the set we get is called whole numbers. And my set of whole numbers will be denoted by capital W. My capital W set starts from 0, 1, 2, 3, 5, 6, and so on. The numbers are also continuous. They run up to infinity. The difference between these two is that for the natural numbers, my set starts from 1. And then for the whole numbers, my set starts from 0. Many of our candidates confuse the two. They cannot differentiate between the whole numbers and the natural numbers. So take this noted. Whole numbers start from 0, and then the natural numbers start from 1. So far, those are two types. My other type, which is number 3, we can have prime numbers. The prime numbers, first of all, are numbers that have only two factors. These are numbers that have only two factors. They have only two factors, that is 1 and the number itself. They are simply numbers that have only two factors. They don't exceed two factors. And those factors we are talking about include 1 and the number itself. I will take a look at a number like 2. How do I know that 2 is a prime number? When I divide 2, for example, by 1, 2 divided by 1, I get 2. Then I have 2 divided by 2, I get 1. There is no any other number that can be divided by 2. Meaning that it has only 1 and 2. The answers I'm getting are simply 1 and 2. It has only two factors. 1 and the number itself. The number itself is 2. So 2 qualifies to be called a prime number. When we go to a number like 6 divided by 1, I get 6. 6 divided by 2, I get 3. Then 6 divided by 3, I get 2. The numbers I have here are simply 1, 2, 3, and then 6. 6 has 1, 2, 3, 4. 4 factors, meaning that 6 is not a prime number. Why? Because it has more than 2 factors. Prime numbers are numbers that have only 2 factors, 1 and the number itself. So when I go to the list or the set of my prime numbers, which is denoted by capital P, my set will simply be, is 1 a prime number? When we talk about 1 divided by 1 is 1. What about 1 divided by 2? 1 has only one factor itself, so 1 is not a prime number. So when I'm listing the set of prime numbers, I start from 2. We have 3. 4 is not a prime number. I have 5. I have 7. 9 is not. I have 11, 13, and so on. So when we say prime numbers, we simply mean numbers that have only 2 factors, 1 and the number itself. So far I have my 3 types. My 4th type of number, we can have what we call composite numbers. So if you have understood what prime numbers are, then composite numbers is simply the opposite. Composite numbers, first of all, are numbers that are not prime. Meaning that here, the composite numbers have more than 2 factors. For them, they have more than 2 factors. So the numbers that were not in the set of prime numbers then qualify to be called composite numbers. And among the numbers that are missing here, we have my set C. I will have here I have 2, 3, meaning that I start from 4. I have 5, 6 is missing, so 6. I have 7, meaning I have 8, 9, 10, 12, 14, 15, 16, and so on. That is the set of composite numbers. Numbers that have more than 2 factors. My other type of numbers, we can have what we call even numbers. Even numbers. Of course, these are numbers that when they are divided by 2, they don't leave any remainder. They are numbers when divided by 2, leave no remainder. And among the examples examples of even numbers. We have 2, 4, 6, 8, 10, 12, and so on. Because all these ones are perfect divisors. When they are divided by 2, they don't leave any remainder. My other type, which is number 6, we have odd numbers. So unlike the even numbers, the odd numbers, for them, when they are divided by 2, they leave a remainder. And among the examples of odd numbers, we have numbers that are not included in the set of even numbers. We have 3, because 3 divided by 2, I have 1 remainder 1. When I divide 3 by 2, I simply get 1 remainder 1. So 3 is an odd number. I have 3, I have 5, 7, 9, 11, 13, and so on. The list is continuous. And we have so far natural numbers, whole numbers, prime numbers, composite numbers, even, odd. Number 7 will be, we have square numbers. If someone tells you to square a number, what do? Square numbers are gotten by multiplying a number by itself. For example, if I have a natural number like 1, to get the square of 1, I simply have 1 times 1, and my answer is 1. Here we have 2 times 2, 4. 3 times 3, my answer is 9. 4 times 4, my answer is 16. We simply get the square numbers by multiplying a number by itself. So my square number set, which is S, is simply the products we get after multiplication. And my answer is simply 1, 4, 9, 16, 25, etc. The list is endless. But remember, these answers or products are obtained by multiplying the number by itself. That is our type number 7. Then number 8 of the types of numbers. Our number 8, it can be tube numbers. The tube numbers. So of course these are gotten by multiplying the number 2 times. Here we multiply the number by itself. So these are tubes of edges. For example, if I have a natural number like 1, to get a tube number, I multiply the number 2 times. So my answer is simply 1. Then I have 2 times 2 times 2, which gives me 8. I have 3 times 3 times 3, which is how many? 3 times 3 times 7. I have 4 times 4 times 4. This is how many? You tell me. So the set of tube numbers, which is denoted by C, is given by 1, 8, 27, and then the list is endless. But then we are supposed to multiply the number, which is the natural number, multiplying 2 times. It is multiplying the number, which is tubes of numbers, of edges. And then I have 9, my other type, which is, which type? We have triangular numbers. Triangular numbers. Of course, these are more of a triangle, and we have a triangle here. I have 1. To get the triangular numbers, we simply add on every successive interval we add 1. And we have, for if this is 1, of course 1 remains 1, and then we are adding successively. I have 0, 1, and then 2. So this was 1, meaning that I am going to add a 2. 1, 2, 3. My answer now is 3. If I had 2, then here I'll have 1, 2, 3 of them, meaning 1, 2, 3, 4, 5, 6. I get 1 plus 2, and now plus 3. My answer now is 6. Then I have 1, 2, 3, 4. How many are those? I get 1 plus 2 plus 3 plus 4, giving me 10. Then I have, these are 4 and 1 to 1, 2, 3, 4, 5. So I have 1 plus 2 plus 3 plus 4 plus 5, which is how many? 15. So my set of triangular numbers will be simply 1, 3, 6, 10, 15, and of course the list is endless. We simply add successively. I had 1, I got 1 plus 2 to get 3. Then here I had 1 plus 2, then again plus 3. You see, I am adding 1, 2, 3, 4, 5 to get my set of triangular numbers. And one other type of number we can talk about my other one type of number we can talk about is called, which is number 10, Fibonacci numbers. Fibonacci numbers. How we get them? We simply get them by adding the last 2 digits. For example, we have a set of whole numbers, and my whole numbers are simply 0, 1, 2, 3, 4, 5, 6, and so on. That is my set of whole numbers. Now, to get the first number, we are simply saying that to get Fibonacci numbers, we simply add the last 2 digits. We add the last 2 digits to get the next number. So, if this is a set of my whole numbers, when I get 0, my first number will be 1. 0 plus 1 gives me 1. Then I have 1 plus 2. I am simply getting these last 2 to get the next number. When I start with 1, of course, in my first set, I start with 1. Then to get the next number, I will have 0 plus 1. And this gives me 1 also. My 1s are now 2. 1 was the start for natural number. But then to get to the second one, I simply added these 2. We are adding the last 2 digits to get the next number. So I get 0 plus 1. That's why I have 1. And then, what will be my next number? To get the next number, I will get 1 plus 2. 1 plus 2 gives me 3. And then, how do I get to the next number? My next, I am simply adding the last 2 digits to get the next number. My first number is a natural number, that's why I have 1. And then here I have 0 plus 1 to get my other 1. So to get the next number, if it is, for example, a sequence, I'm simply going to get this plus this, and my next number will be 2. To get the next number, I'll get this plus this. My next number will be 3. To get the next number in the sequence, I simply have 2 plus 3. And my next is 5. Then I have 3 plus 5, which gives me 8. I have 8 plus 5, which gives me 13. How do I get the next number in the sequence? Simply add the last 2 digits to get the next number. I have 8 plus 13, and this is 21. How do I get the next? I get 21 plus 13. This is how many? 34. And of course the list is continuous. We are simply saying that you add the last 2 digits to get the next number. I started with 1. Of course, here there is an imaginary 0. And to get the next number, it is 0 plus 1. That's why I have 1. To get the next number, meaning that I will have 1 plus 1. Because my last two digits are simply 1 and 1. That's why I have a 2. And then to get a 3, I have 1 plus 2. That's why I have 3. Then 2 plus 3, 5. 3 plus 5, 8. 8 plus 5, 13. And the list is continuous. So there are very many types of numbers. That's about we can cite some of them. Like we have said, whole numbers, natural numbers, prime numbers, composite numbers, square numbers, triangular numbers. The types are very many. Then when you go ahead, you look at the fractions. Of course, fractions are also numbers. How to add fractions, how to subtract, how to divide. We have decimals, they are also numbers. How to deal with decimals. But then, so far, these are the types of numbers. Then we can go to working with numbers as our other subheading. After the types of numbers, we have working with numbers or operation of numbers. And we have examples. So we shall simply be looking at some of the examples that involve the knowledge we have obtained about numbers. And our first example says, given the sets, I have set A, and my set A is simply all natural numbers between 10 and 30. And then set B is simply all prime numbers, also between 10 and 30. The first question is that we find the members of A intersection B. And then the second question, we find the number of A intersection B. So this is actually so simple, and in most cases these are section A numbers that take 4 marks. But then if you know what prime numbers are, you know what natural numbers are, other questions could be triangular numbers, could be composite numbers, then you're able to get your 3 marks. To start with, I have to list the members of set A and natural numbers. Remember, natural numbers are counting numbers, but then not all of them are needed. We want a range between 10 and 30. Which numbers are those? List the numbers. They have to run from 11, 12, 13, 14, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, and then 29. Of course, we don't include 10 and 30. We want numbers that are between. Then my set B is simply prime numbers. If you remember very well, we say prime numbers are those numbers that have only 2 factors, 1 and the number itself. So the prime numbers that are between 10 and 30, you can cite 11, 13, 14, 15 is not, 16 we have 17, 18 we have 19, 20, 21, 22, 23, and we have 29. This is my set of prime numbers. So question A, my question A or Roman 1, we have members of A intersection B. If we go back to the sets, you're aware we have union, we have intersection, we have complement, but then with the intersection, we simply mean the members that are both in set A as well as set B. And we can cite those members either by circling or by ticking. So to cite the members that appear in the 2 sets, in set A, I have 11, 11, 13, 13, I have 17, I have 19, 23, and 29. Actually, all the prime numbers are also natural numbers. And so my A intersection B will be equal to 11, 13, I have 17, 19, I have 23, and then 29. That is Roman 1. Roman 2, we are supposed to find number of A intersection B. And number of means that we count how many elements appear in either set A as well as set B. And my elements, when we count together, are how many? We have 1, 2, 3, 4, 5, 6. So my answer is simply 6 elements. So operations of numbers, it could be sets, it could be finding the next number in the sequence. We list for you and we tell you find the next number in the sequence. You have to be keen about which type of numbers were used and so on. So this is one of the examples. We can have another one which is 2, but then this one you're doing it in your free time. And because we have 2 sets given set P, and my set P here we have composite numbers. The composite numbers that are between also 10 and 30 is my set P, and then set 2 we have odd numbers also between 10 and 30. You're supposed to find Roman 1 P intersection 2, Roman 2 number of P intersection 2. So set P composite numbers. We have talked about composite numbers. We have seen what odd numbers are. Like I said, it could be any type of number that can be asked about. So take note of the types, differentiate which is which, and you'll be able to pass such type of questions. So this can be done in your free time as we come back or we meet again. I wish you the best. I remain Numerical, a teacher of mathematics. Hope to see you again. Stay safe, wash your hands, keep a social distance, and please read hard, because this is not the end of your education. More is still coming. Subscribe to our channels. Keep in touch.